Hi, I am Varun Joshi and welcome to day 59 of our Certified Kubernetes Administrator 2025 course. This is the last lecture in the series. You and I have come a long way from Docker basics to cluster basics to Kubernetes deep troubleshooting. We have had a long journey. Today, we will master JSONPath with kubectl so you can extract exactly the fields you need fast, exam style, and production ready. Here is what we are going to cover in this lecture. Kubectl get pods. What happens under the hood when you run this command? We will do a quick YAML and JSON refresher. We will discuss the similarities, differences between YAML and JSON. We will then understand the why and what of JSON path. And finally, we will do some practical walkthroughs. So let's get started. So I'll go to my GitHub notes and here are the prerequisites for day 59. And the prerequisite is you must understand YAML, and we discussed this in greater detail in day 9. So if you have any confusions pertaining to YAML, what are objects, what are lists, how they are used in Kubernetes, then I would suggest you go and watch day 09. With that understanding, let's get started. kubectl get pods. So what happens under the hood when you run kubectl get pods? Here is a user Shwetangi, then you have the kubectl client, and here is the API server, and then there is the etcd. Etcd, as we know, is the data store of your cluster. API server is the entry point of your cluster. So whatever you see here is part of the Kubernetes cluster, and whatever you see here is part of the jump host or the thin client that you are using to interact with your Kubernetes cluster. As soon as Shwetangi runs kubectl get pods, the kubectl client will come into action. We know that kubectl client at large performs these three actions, but validation will not be performed right now because it is a get command. We are reading something. If we were creating something, then validation would have been performed and kubectl client would have verified your YAML syntax and also the basic Kubernetes schema. So here we are just running kubectl get pods. First, kubectl client will read the kubeconfig file to see against which API server this command must be run. Additionally, your kubeconfig file also holds the authentication information that this kubectl client must use when it is authenticating with the API server. Now, as we know, you as a DevOps engineer could be dealing with multiple Kubernetes cluster. Hence, you have something called Kubernetes context, and based on the context that has been chosen, your cluster and user is selected. Now, just to recap, Shwetangi runs kubectl get pods, kubeconfig file is read, and now the kubectl client will formulate this request, formulate in the format that API server understands. Now, me and you, for us, kubectl get pods is humanly readable and understandable. But when it comes to API server understands HTTPS get. So this command will be converted into a format that API server understands, and the API server understands HTTPS. And if you have been through day 35, we discussed these things in detail. What are the API endpoints that are available in the Kubernetes API server and which endpoints are used when you run different commands. And we also understood all these endpoints that you are seeing on your screen right now. So let's move back to day 59. kubectl client forwards the request to the API server in the format the API server understands. Now, API server also performs a validation, but since this is a get request, there is no validation. But if this were, let's say, a create request, or you were applying some Kubernetes manifest, then this would validate the entire Kubernetes schema. Second point is authentication. It will verify that whether user Shwetangi can authenticate with the cluster. Once this part is done, then we will move on to the authorization piece. In the authorization section, API server will validate whether Shwetangi has proper authorization to perform get operations on pods. Then there is admission controller. I want you to know that for get requests, admission controllers are bypassed. But if this were a create request, then admission controller will also come into play. Now, from here, the API server has two options. It can either serve this request from its cache. Now, API server also maintains a cache so that it doesn't have to go to etcd time and again. So if this information is available in the cache, then API server will serve it from the cache. Otherwise, API server will reach out to the etcd, which is the data store of your cluster, to fetch this information. There is a confusion that etcd stores data in JSON format. That is not true. The data in etcd is stored in key value pairs, but that data is in protocol buffer format, also called Protobuf. Now, what is Protobuf? Protobuf is a binary format. JSON is text based, but Protobuf is binary. Hence, it is compact in size. And when something is compact in size, it gives you high performance, which is why etcd uses Protobuf to store the information. And I also want you to know JSON is the format which is used for client server communication. But when it comes to storing the data in etcd, then you would see Protobuf being used. Now, having said that, let's see what happens in the response traffic, because in that section you will clearly understand why we are discussing both JSON and protocol buffer. So etcd responds to the API server that this is the information about the pods. Now API server sends this request to the kubectl client on HTTPS, and this is where the communication initiated. The communication also initiated in HTTPS, that is secure HTTP, and then the reply traffic also goes over HTTPS. And here we are saying that the reply on wire is over HTTPS, and inside the payload the response could be in JSON format or in Protobuf format. Now once this response is received by Shwetangi, it is by default received in the default table format. Understand that upon receiving the response, it is the kubectl client that is converting, decoding the response that is received in JSON or Protobuf format into the format that a user understands. Now here, first the response comes in the default table format, and default table format will just give you this information which we have been seeing since the inception of this course. When you run kubectl get pods, you see this information. And if you want some more information, like if you want to know the IP address of the pod and on which node the pod is running, then you can also add -o-wide. And when you run -o-wide and run this command, the kubectl client will give you the information that you get when you add -o-wide. Similarly, you can use -o-YAML or JSON as well to see all the fields that are associated with a pod. For example, if I go to my terminal right now, if I run kubectl get pods, I see my cluster has 2 pods right now. Okay, but if I run kubectl get pods -o JSON, then I will get the information about these 2 pods, and there are several fields which were hidden from you when you just ran kubectl get pod. So if you add -o JSON, which will give you the output in JSON format, or -o YAML, this will give you every detail about these pods. Hence, what command you run depends on how much information you need. Now, if I go back here, the last one is you can also use -o JSON path. Now, this is the topic of discussion of this lecture. Hence, I will take 1-2 minutes to quickly tell you what this is, and then we will see this in detail. And I also want you to know that if you have that question in your mind, but Varun, if this response here is in Protobuf format, then how will I run JSON path queries? How will I query that? I want you to clearly know that this response comes here, and then the kubectl client converts this response, or essentially decodes this response into JSON, and then you can run your queries. For example, if you run JSON path, and we know, as the name implies, JSON path is a way via which you can query anything JSON. We will look into this in detail later in this lecture, but for now, JSON path is a way via which you can query a JSON document. Hence, you can query whether the received response by the kubectl client is in JSON or protobuf format when you are using JSON path, because kubectl client that's sitting here is doing the decoding for you. I hope the entire flow is understood. Now let's do one thing. Let's discuss YAML and JSON in Kubernetes. Firstly, what is JSON? Now, JSON is JavaScript object notation, a lightweight text-based data format used to exchange structured data between systems. And what were the systems in our previous examples? There were two systems. There was kubectl, and then there was Kubernetes cluster, and these two systems were exchanging data between themselves in JSON format. But Varun, when you ran here kubectl get pods, what is there that you sent in JSON? Understand that when I run kubectl get pods, there was no payload essentially, because I was performing a read operation. But if you were applying, let's say, a manifest, and we humans understand YAML in a better way, you could write your manifest in JSON format, but we prefer YAML because YAML is humanly readable. But why I brought you here was, when you run kubectl apply -f, then a file name, and let's say that file is creating a pod, whatever the format is in the manifest, if it is, let's say, YAML, then your kubectl client will convert that payload into JSON format before sending it to the API server. So this HTTPS request will also have that payload in JSON. Here we were performing a get operation, which is why you see get here. If we were creating a pod, you would see a create verb here, and that create verb will have a payload. And what will be that payload? That payload will be your manifest that you wrote in YAML converted into JSON format, which the API server expects. And who is doing this conversion? It is your kubectl client that is building that HTTPS request for you. Okay, so what we understand is JSON is a way via which two systems can exchange structured data between them. Think of it as a universal language of data, similar to how English is a common language for people to communicate. Now, JSON is often used in web APIs. JSON organizes data into objects. Now, what are objects? Objects are key value pairs that are enclosed in curly braces in JSON. Again, I will show you this comparison visually. I'm just giving you a definition right now. You can also have arrays. What are arrays? Arrays are ordered list enclosed in square brackets. It requires double quotes. So whenever you are talking about JSON format, it requires double quotes. It does not support any comments. Now, what exactly is YAML? YAML ain't a markup language, a human readable serialization language designed for configuring systems. It uses indentation and hyphen for lists and supports comments, which adds convenience. Now, I want you to know one thing. We will have a YAML versus JSON in a little while in a pictorial way. But for now, all JSON is a valid YAML, but not vice versa. Why we are saying this? So I want you to clearly know that when I see a JSON file, and I'll show that to you. Here is my JSON file in Visual Studio Code, and this is a pod.json. Here we see one pod that has two containers. I just want to show you one thing. I'll copy this. I'll go to my browser. I will go to JSON formatter. Here I will paste this, and if I click on convert JSON to YAML here, I see this is a YAML that we have been using thus far. So I can do this conversion as is, because whatever is supported in JSON is also supported in YAML. But whatever is supported in YAML is not supported in JSON. Why, Varun? YAML supports comments, JSON does not. YAML supports line separator. We have used hyphen to have multiple YAMLs in a single file, but JSON does not support that. YAML also supports multi-line blocks, and we saw this when we were discussing config maps. Hence, this line is proved, which says all JSON is valid YAML, but not all YAML is a valid JSON. kubectl accepts YAML or JSON manifest. Like I told you, we prefer YAML because it is easy to write, but you can also write your manifest in JSON format. For example, if I have this file here, I run kubectl apply -fpod.json, then a pod with two containers will be created for me. So if I go back here now, on wire writes JSON body over HTTPS to the API server, and we know that. So if we are sending something, then it is converted to JSON and then sent over HTTPS to API server. This is what I told you. When it comes to reads HTTPS request, server returns JSON or Protobuf, and this is what we saw here. Then for querying and automation, think in JSONPath, but when it comes to human readability, if you are creating your manifest, then you would be using YAML. Now let's discuss how they are similar. Represents the same data. Now objects, maps or dictionaries, arrays are also called lists, and scalars. What are scalars? Scalars are your primitive data types like strings, integers, floats, booleans, null. Now let's discuss how they are similar. Second is can be converted, and we just saw this. So if I go to my browser, I added a JSON and a corresponding YAML was given to me. Now if I come here, field paths are same. Now what do I mean by that? If you see here, under metadata we have name. Similarly in YAML, under metadata we have name. If I want to go to labels, it is under metadata, and here as well the labels are under metadata. So the field path is the same, but what are the differences then? Mental model is YAML's indentation maps to JSON's braces or brackets. YAML list items in hyphens, as we have seen. I'll show you the YAML in a little while. Map to JSON array elements, which are given in square brackets. Now let's see few of the other differences. YAML, human friendly; JSON, machine friendly. Syntax, you would use indentations with hyphens for list. This uses curly braces for objects and square brackets for arrays. It also uses commas, and we'll see this in a little while. Comments, yes, in YAML it is supported. In JSON they are not. Typical use: config files, Kubernetes, Ansible, Prometheus configuration, and so on uses YAML. JSON APIs, tooling, web app payloads like we just saw. Extensions .yml, .yaml, .json. Style, it is concise, which is why we humans love it. And then there is JSON, explicit and structured. Now I want to do a versus of both these structures. Now firstly, I want to tell you why this starts with a curly brace. Now I want you to know that here we have a single object as in we are creating a single pod, which is why this starts with a curly brace and ends with a curly brace. And this is where the beautification of Visual Studio Code comes into picture. I've taken this picture from Visual Studio Code. And why it is helpful? Because of the color coding. You see, this is in white and this closes in white, so these two are related. Here this opens in pink and then it closes in pink. Here this opens in green and closes in green. Similarly, it opens in green and closes in green. I think this is cyan, not green, for the color conscious people. Now we understand this part, and same applies for square brackets. This square bracket is in pink and then it closes in pink. Here as well it is in pink, it closes in pink. Here this one opens in cyan and this closes in cyan. So understand these points, understand the color coding to know where your error is. Now that we have that understanding, here metadata is a dictionary, and here as well metadata is a dictionary. In the labels section, labels is also a dictionary, which is denoted by curly brackets. So any dictionary here is denoted in curly braces. In JSON, curly braces are used to denote an object, and again you would see people using a lot of terms interchangeably. So if you heard objects, maps or dictionaries, all three mean the same thing, but the correct way to say is objects. Similarly, arrays and lists, they imply the same thing. So you will hear arrays and lists used interchangeably. For this discussion I will mention objects, but understand, if someone says maps or dictionary, they are essentially meaning the same thing, but the correct way is object. So what here I'm saying is all the objects in JSON are depicted in curly braces. So here is one, here is another. Then spec section is also a dictionary, so that's why you see curly braces here. Then here containers, in YAML we used hyphen to denote the list. So containers is a list here. Here also containers is a list, but the depiction is in square brackets because this is JSON, and here the depiction is in hyphen because this is YAML. This is the only distinction. Rest, spec is dictionary here as well, spec is dictionary here as well, containers is a list here and containers is a list here, metadata is a dictionary here, metadata is a dictionary here. As simple as that, no rocket science. API version is a string here, API version is a string here. It does not change the structure, it just changes the representation. expectation. So here containers are, there are two containers. Similarly here there are two containers. The first one is this and the second one is this. I hope this distinction is now clear. Now we have this understanding. Let's move to the next section. Next is why and what of JSON path. So up until now we have a clear understanding of what is YAML and what is JSON. But what is JSON path? And before understanding what is JSON path, let's understand why JSON path. In real clusters, you will have thousands of objects. Scrolling the full JSON every time is slow. And here we just had two pods and you saw how lengthy of an output we received. What if I just wanted to know the images that are being used by my pods, nothing else? And if you see this example, if I run kubectl get pods, let me spell it correctly. If I run kubectl get pods here, if I have to fetch the images that are being used by my pods, then that output should be just of 3 lines, because this pod only has one container, so one image. This pod has two containers, so two images here. So I should just have 3 lines of output if I want to fetch the images that are being used by my pods. But there is no way I can do this with what is available with just kubectl. To get that information, I have to use JSON path, which is used for filtering things. And here I just have 2 pods. When you are dealing with real clusters, your namespace could have thousands of pods. You could have 10s, 20s, 50s deployments in your cluster. So to fetch the information appropriately when you are dealing with such heavy clusters, you need something that will give you exactly what you need, the fields that are needed. That's it. If I want to fetch taints and tolerations of all my pods, then I should have a way via which I can fetch the tolerations that are defined for my pods. If I want requests and limits, I should be able to do that. So what we want is pull only the fields we care about, filter lists to just matching items, output clean script ready values and lists, avoid paging through huge JSON YAML dumps. Now this is where JSON path comes into action. What exactly is JSON path? JSON path is a query language for navigating through your JSON document. So if you have a JSON document, you can query it using JSON path. Now it could be a static document, which I will show you in a while, or it could be live Kubernetes objects. I want you to clearly know that the output that the API server sends to the kubectl client is in JSON format, but you are only shown human readable results. You are not shown the entire JSON. You can further use these commands to only get what you want. So let's come here and read the next line. kubectl-o JSON path applies the query to the decoded API object even if the wire used Protobuf, and we understood this in the beginning of this lecture. Now I want to discuss core operators. Now these core operators are the ones that you will be using 90% of the times. Now what is $? $? is the point where everything starts. So this is the root of the document. Then there is a dot, that is the child field. Example, if you want to know the name, then you would traverse from the very top. So first there is the root, then there is metadata, then there is name. So if I go to my browser, first there is root, then there is metadata, and then there is name. Similarly, if you see the JSON, first there is the root at the very top, and then you have metadata, and then you have name, which is why we are running this command to know the name of an object. Now that object could be a pod, deployment, config mapper, whatever. That is based on on which document you are running the command, or in which live object you are running the command. And we'll do both the things. We will first run the commands in a static file, and then we will be running the commands into live Kubernetes object. Now there is a list here, that is array example spec.container. If I have this 0 here in square brackets, that implies I want the first item in the list. So if I go to my browser, if I see here, this is a list, container is a list which has 2 items. So if I specify 0, then this will give me the first item in the list. If I specify 1 here in this square bracket, then I will get the second item. As simple as that. The next one is wildcard. What if I want to know the image that is being used by all my containers? Then all is your asterisk, which acts as a wildcard dot image. Now what do we use question mark for? Now filter inside arrays. If you want to filter further with the information, for example, inside containers, I don't know the index of that item. I don't know whether it is at the 0 spot or the first spot or the second spot. What I know is the name. The name is web. I want you to get the information about the container whose name is web. This what you see here at the rate or the question mark, these are part of the syntax, and as we see examples, you will understand them further. So I hope this gave you a perspective of how JSONPath works. Now let's go to the Visual Studio Code and do some demos. I am in day 59 right now. Day 59 has one file that is called pod.json, and here I want to show you how you can query a static file. So we have a JSON document. We'll be querying this document. I will write JSON path first. Now you will have to install the JSONPath utility in your operating system to run these commands. I'll let you figure out how do you install that. So I'll write pod.json because this is the file I want to query. I am in day 59 itself, which is why I can directly specify this. I will press one space here. I will add a single quote, and then I will write the root first. Okay, I want to get the kind of this object. I'll close this. I'll press enter. Simple. I got the kind is pod. I want you to understand that the output that you have received is in a list format. So keep this in mind. Now what I can do is I can add metadata here. If let's say I want to get the name, I'll press enter. This will give me the name. It is 2 containers demo. That is the name of this pod. Then what I can write is I can further see it. I can write name dot, let's say, labels. I want to fetch the labels. I'll press enter. Metadata. Oh, metadata labels. It's not names here. I should just omit this. You have to walk the tree like that. So root, then metadata, and inside metadata there is labels. So previously I wrote name here. Metadata does have name, but it does not have anything labels inside that name. Here I have metadata, and inside metadata directly there is labels. So if I press now enter, it will give me the labels as well. Now let's be a little advanced. So what I will do is let's go to the spec section. I will add spec here dot containers, and then I will add these square brackets here. Now we know containers is a list, which is why I have added square brackets dot. Let's just write this. Oh, sorry, I should close that single quote, and I'll press enter. So here what is happening is spec.containers, this has listed both the containers. So this is the container 1 and this is container 2. So both the containers are listed. Now what I want to do is I want to just list the first container. So I'll add 0 here. I'll press enter, and this will just list the first container for me. Now let me clear my screen. I'll press the up arrow again, and I'll use the wildcard. But now what I want to know is I want to know the images that are being used by my containers. Now understand, if I write images like this here, it won't understand it because it is image, not images. So if I remove this s and press enter, this will give me the first container is using nginx 1.27, which is here, and the second container is using busybox 1.36, which is here. I hope this makes sense to you. Now let's do one more thing. I want to do spec containers, and let's go to ports. And if I press enter, I have ports here. It will just give me container port 80 because we have not defined ports for this container. We have just defined it for this container. Now I hope this has given you some clarity on how to query a static file using JSONPath. So I'll clear my screen now. Now I will take you directly to browser, and from there I will show you different things that you can do using JSONPath. Here what I will do is I will go to this using JSONPath with kubectl. We will practice this now. So firstly, what is the syntax? Kubectl get this kind could be any pod, config map, whatever object supports, you can add it here. The name of the object, then -n namespace, -o output I want in JSON path, and that JSON path here you specify that path precisely. So this is how you will do it. Now let's see one by one a few examples. So first I will copy this. You do not have to understand it right now. I'll just copy it. I'll go to my terminal, this time this terminal. I will run kubectl get pods so that you know I have 2 pods in my cluster. Okay, now I will paste that command here. I'll press enter, and this has given me the name of both my pods. Now why this has given me this information? Firstly, I want you to know that whatever commands you are running, if you are learning right now, first see how the output looks like if I just output that in JSON format or in YAML format, and then you can create your query. So understand that the structure for YAML and JSON is similar. How they are representing the structures is different, but at a very high level the objects and arrays are used. How they are represented, only that part is different. So if I run kubectl get pods -o YAML here, I will get the information in YAML format. If I write JSON in JSON format, so let's get this output in JSON format first. I'll press enter, and this has given me this much information for just 2 pods. And I will now tell you how come I wrote that and got this output. So what I did was I wrote this and I got the name of both of my pods. So kubectl get pods -o JSON path, this is part of the syntax. Then I told you that whatever you write in JSON path should be in single quotes. And here I am saying is first is items. And why do I know I have to write items here? Because I see items here. Understand, root is the $sign, but I have not written the $sign here because Kubernetes will add that automatically. Essentially, the kubectl client will add that automatically. You do not have to mention it explicitly, but keep in your head that the $sign is always there because it starts from the root. So first you have a $sign dot items, because you see items is directly here. So you write items. Now items is a list. How do I know items is a list? Because it starts with a square bracket. Again, if you have not watched YAML tutorial, do watch it, because there we understand crisply what are objects, what are lists, and so on. So do watch that. Now here I have items. Now I want this detail for all the items. Here the first item is, let's say, pod 1, and the second item would be pod 2. So I want this information about all the items. That is why I have a wildcard here. Then I'm saying dot metadata, and then inside metadata I want name. So here is the name. So first it gave me information about both my pods, because I am using a wildcard here. If you had 1000 pods, then you would have 1000 names mentioned here. I have a /n here. This is for the new line. So if I do not add this, I will get output in this format, which I don't want. You see a %sign is there. To remove this, I added that -n there. Sorry, \n there. So let's go back to our browser and then see the next command that I want to run. So here first I will copy this command, then I will paste this command here, and here it is asking me to provide a pod name. So now I am trying to get the pod IP and the node on which my pod is running. So I will add, let's say, my pod here, and when I press enter, this will give me the pod IP. So here the first is this, and then -t is I want a tab here, so that's why I have spaces here. And then I want spec.node name. So node name is CKA worker 2. This is the node where my pod is running, and this is the IP of my pod. So if I run kubectl get pods -ovide, you see kubectl get pods -ovide kubectl, and you see my pod has this IP which we saw here, and it is running on CKA worker 2. So I hope all these things are getting clear to you. So I'll go to the browser again, and now I can run this command, and this is an important one, so I'll take some time to discuss this. I'll clear my screen, I'll paste this here, I'll press enter. Now what I am saying is I'm using a range here. Range is like a for loop, and then we are ending that loop here, and you see end here. So what I'm saying is go to all the items, as in all the pods, and then I want you to go in the spec section there, in the containers section there, all the containers, and get me images of those containers. So you see, this is the nginx image that my pod was using, and these are the images that my second pod is using. My second pod has 2 containers. The first container is using this image, the second container is using this image. So the important takeaway is range is for applying a loop, and then you end it using this. /n we understand is for the next line. I'll go back to my browser again, and then you can run these similar commands for your deployments, for your services and endpoints. And then finally, this is what I want to show you. I want to show you how to get information about certain nodes. So I'll paste this here, I'll press enter. This will give me information about my nodes. And you see, I thought this is only a single node. So these are 3 nodes. I have 3 nodes in my cluster: first, second, and the third node. So if I run kubectl get nodes, you see I have 3 nodes in my cluster. Then I want to run this, and I'll show you what information this will give me. Again, you can have multiple permutations and combinations, but all of these depend on your specific requirement. So I'll press enter, and this will give me whatever information I asked about my nodes. And again, I am using range here, which runs a for loop, and here I am ending that loop. And then I will recommend you to go through the GitHub notes and see what are the best practices and some of the pro tips that you can use. So that wraps day 59. JSON path with kubectl. You learned how to think in JSON even while authoring in YAML. Use JSONPath to pull exact fields and filter arrays. And with this session, we complete the CKA course aligned with 2025 curriculum. I will keep adding videos as needed based on exam feedback and ongoing research. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.